Hey, good afternoon, good evening, and good morning, those who are joining from different countries. Thank you for joining us today. Let's wait for 2 more minutes and let others to join in this webinar. Yeah, be patient and for 2 more minutes, let's wait for 2 more minutes. Hey, thank you. So, you are based out of the Hyderabad. I hope you are aware of that. Some of you are aware of that. And not in Hyderabad, but all over the India at many places. The monsoon is at peak. Yeah, and today we see that lot of cloudy and rainy. I hope at many places in India is same situation. So anyway, so once again, good afternoon, good evening, and good morning for those who are joining from different countries or different parts of the world. So thank you again for joining us today. Welcome to today's webinar. Topic is Intricacies of Rotating Machinery Vibration Analysis, brought to you by Spectrances. Yeah, so I'm Kotia Naik, Principal Instructor at Spectrances, and I'll be your host for today's session along with our speaker and panelist. So Mr. Subbarao Ganti and panelist Mr. Gopi, my colleague, is here. Yeah. Before we get started, so I wish to share some of the important information with you. So this webinar here today is being recorded, and the recordings of the webinar will be shared on our website and YouTube channel. Please feel free to share the information with your friends and colleagues, those who are not able to join today's session. I hope you are able to see my screen. Yeah. So I'm pleased to share with you about the Spectrances. So we are from Spectransis, and this webinar is brought to you by Spectransis. The Spectransis is a technology-driven company that focused on two key areas. One is employability-focused education that helps individuals develop the skills and knowledge necessary to succeed, and asset reliability digital solutions that help organizations to increase the productivity and reduce the downtime. Spectransis' mission is to enable success by providing the innovative solutions and training that empower individuals and organizations. The success of individuals and organizations. We understand that success is not a static destination, but a continuous journey of adaptation and improvement. Our commitment to developing the skills for now and the future is rooted in our belief that empowers individuals and businesses. For this, we have built an personalized learning ecosystem that help individuals and organizations. It's a complete learning holistic solution under expert guidance. It provides skill up courses, skill up and certification courses, and experiential learning through our mentors and experienced professionals. And we provide hands-on practice, and also we provide the employability enablers. As a holistic learning solution under expert guidance, we help people to turn their passions into profession. This ecosystem is a gateway to career success and talent pool. We bridge the connection between the potential candidates who are looking for opportunities and companies who's looking for a talent. Yeah, by facilitating this connection, we create a win-win situation for both parties. We enable individuals to find meaningful opportunities that align with their aspirations and provide employers with the access to the pool of skilled and certified people who can drive their organization forward. So in this ecosystem, it helps employers to access the right profiles and find the best talent match. They can directly schedule the interview with the candidates, and also they can hide the best talent from this platform. It's a end-to-end solution to source the right people. Yeah. So as some of you are aware of that, our principal association with the industrial press, where we provide the original printed books from the industrial press. We are the exclusive partner in India. We can provide these original printed books in India. And we are also partnered with the Mobius Institute, who is the world leading company in maintenance, condition monitoring, and reliability trainings and education. In conclusion, what you can expect from us: learn at your own pace, learn from the best professionals, meet and interact with the expert teachers, and career assistant platform to find the right opportunities for you and grow your career with the employers network. So our delivery model is like a classroom and virtual instructor-led trainings and private and on-site trainings we provide, and also the self-learning online video courses we provide. And the top categories are condition monitoring, asset reliability, maintenance management, oil and wear particle analysis, NDT, non-destructive technologies, and some mechanical design courses. So you can see all these our top category courses on our website. and some of the best trainers you can see. We are aligned with the many professionals. So one is myself and Sir Dr. Subbarao Ganti and SKM Rao, Arun Babu, Munna Nayak, and NP Sundar. They are specialists in their area. So those who have almost like 35, 30 years of experience. And we'll just let you know that we are collaborating with these peers to deliver the comprehensive training and services that propel your success to the new heights. So I just want to let you know that there's going to be a next webinar on the 16th September, Saturday at 10 a.m. to 1 p.m. It's a 3 hours of webinar, live webinar, and that we are hosting from here. And the topic is challenges of turbomissionary vibration analysis. We'll be discussing more on the different plots and how we analyze the plots and all. So the challenges of turbomissionary analysis. It's going to be 3 hours of webinar, and since it's a long duration, 3 hours, so we are charging very nominal fee for that. So that's going to be we'll let you know that, and there'll also be link shared with you to join that webinar, to register for that webinar. Yeah, so in conclusion, our mission is to enable success by developing skills through collaboration and by bridging the gap between the talent and employers. We strive to create an environment where achievement knows no bounds. So that being said, if anybody has any questions throughout the webinar, please go ahead and type them in the question panel on your go to your webinar screen. And today's session is all here focused on our attendees, which is all about you. So we are here today to answer your questions throughout the session. Once again, thank you for taking time out of your busy schedule to attend the webinar. Thanks again. So that all being said, it's my pleasure to introduce our speaker, Mr. Subbarao Ganti. And Mr. Rao is a trainer and consultant, and he has a 35 plus years of experience, and he's a vibration analyst CAP 4. So over to you, sir.
Thank you, Kotya. Thank you very much.
Yes, sir.
Okay. You're able to see my screen, right?
Yeah.
Okay. And I'm audible. No issues from the audio point of view. Okay.
Yes, sir. Everything is good.
Okay, great. Thank you. Thank you, Kotya Naik, for this opportunity to speak on this intricacies of rotating machinery vibration analysis seminar, and a hearty welcome to all the participants from various time zones. Today is going to be an interesting discussion. I'm going to discuss interesting topic I'm going to present before you. And before a few minutes ago, I was having a chat with Kotya, and he was saying that some people have expressed their interest in this, coining the title of this presentation, the intricacies. So what do they were trying to see, understand what do I mean by these intricacies of rotating machinery vibration analysis. So of course, let me show you what I would like to present here. So the purpose of this talk is basically to intended to be a guideline for the budding vibration analysts, highlighting the intricacies involved in the vibration analysis. Now, when I mean the intricacies here, if you refer to any English dictionary, the meaning it gives out is looking at the greater details of the finding out the complete details of an activity line. So here in this module, I'm going to show you the intricacies or the complexities or the elements that are involved in the machinery vibration analysis. I'm not looking at the convention in this module as it unfolds. You can understand that I'm not going to discuss the conventional problems like unbalance, misalignment, and how to address them and all those things. But more than that one, the mindset that is important to address these problems as a global approach. That's what I'm going to really focus on present. Actually, this talk has come out of my experience, or as has been told, that more than 35 years of working in various organizations and looking at various industrial machinery. So I would like to show like a torch, a path for the coming up, the vibration analysts are all the people who are already in this field. That's the purpose of this presentation. So normally at the starting of the career as a field vibration analyst, it appears that all the machinery issues could be addressed with the spectra, time waveform, and phase data. That what was I was also thinking. And also most of us have in our offices or at in our in the somewhere we'll be hanging the wall charts also, which tells us how does an unbalance present itself, how does bearing problems present itself, and all those things. But as field engineers, we all know that the situation is much more complex than what the charts speak to us. Now, when we address these machines here, we may be speaking about a small motor driven fans of a few kilowatts capacity, or you may be addressing a very large gas turbine as big as 210 megawatts capacity. The problem is the same, and the complexity is going to be the same. The approach is going to be the same. It is just like when you see when a doctor sees a patient, whether he's a child of 4 years or an old man of 70 years, the patient is a patient. So it doesn't make any difference. The process and analysis remains the same. So the intricacies or the complexities are going to be the same. So now when we are looking at this particular issue, the challenge is as to how to identify the problem and address it in the right way. Now, in order to identify the problem, we should understand what are at what stage of the machine's life the problem is likely to be introduced there. So according to me, when I thought over a process and all those things, and of course I have attended various training programs and I have read many books and all those things, the same information has been presented. It's not, what I'm going to speak is not something new or which is discovered or totally made by me. I'm just trying to compile the things and put it in one format, which I thought is a convenient way of understanding the process. So the 7 stages at which in any machine's life, at which a problem for the vibration can enter is as shown on the slide for you here. The first stage is the design stage, and the second stage is the engineering stage. Now, many people use the word design and engineering in an interchangeable way. But I have something specific in mind when I use the word engineering, and we will get a clarity as we go into the further slides there. And then the third stage at which the problem can be introduced is the manufacturing of our equipment. And then the fourth stage is the installation or the erection process. And the fifth stage is when the machine is put into service for the first time, that is the commissioning process. And then once that is done, the machine are handed over to the operation people, and then some problems can be introduced at this stage in the process of by the operational process. And then finally, the 7th stage at which the problems can come into this is the maintenance. So the maintenance of these rotating machines. So these are the 7 stages at which a vibrational problem can creep in. But we will be measuring at, we will not be, as vibration analysts in the field, we are not looking at the design aspects or the engineering aspects or the manufacturing or installation or anything. We just stand before the machine when it is running and we collect the vibration data and then try to analyze the problem there. But if the problem, whether the analysis and the solution shall be simple or complicated, basically depends upon at which stage the problem is initiated. And now, most of us are graduate engineers or diploma holders or whatever it is, our technical qualifications. We do not have a complete understanding about the equipment, its design or its engineering or manufacturing process and installation complexities and all those things. We only just collect the vibration data and try to identify the problem on the machine. So, most of us are not fully equipped with the knowledge and expertise to resolve the vibration problem if they are coming from any of these sources, like in the design stage or the engineering stage or the manufacturing or during the installation process there. As most of you have seen as a practicing field engineers, when such type of problems are coming up, most of the plant owners, they fall back upon to the OEM, the original equipment manufacturers, or they hire the special consultants who are experts in their respective fields and to address this problem. It is not a simple problem of a vibration analyst there, if it is basically related to the design engineering stages. And many of the field vibration analysts do not have an understanding of these 7 stages concepts and the limitations thereof in analyzing the vibration problem. As a vibration engineer, I don't have, what I should realize is I don't have the complete capability of analyzing, of finding a solution for an existing vibration problem. I can definitely find out a solution if under the certain conditions only. It is just like this. To give you an example, we all these vibration analysts can be compared, our profession can be compared to a general physician, a doctor, a general physician doctor. Most of us, when we fall sick for whatsoever reasons, the first thing is we try to approach the general physician there, and then he tests us. He discusses with us, and based on the symptoms we present and the other small tests he carries out, then he will be able to identify from his side whether the disease is something which he can treat it or not. If he feels that it is a normal viral fever, he says that, okay, please take this medicine, and then you'll be cured within a span of 4 or 5 days. And yes, the story ends there. So after 4 or 5 days, you'll be normal to back to your duty, and you are hale and healthy as before. So just like this one, the same you can compare. You say that there is an alignment problem. Maintenance people will stop the machine, they'll realign the machine, and you start the machine, and the vibrations have disappeared or reduced. So the problem ends there. Similarly, you find that there is an unbalanced component on the machine there. You balance the machine and reduce the vibration. The story is a happy ending. However, what we should understand is that there are certain problems which cannot be addressed in this way. So similarly, a general physician, after at certain stage, some of the problems he'll find out and say that, sir, this problem is not a simple one which I can deal it. You need to visit a cardiologist if you have some heart problem. Or he'll say that you need to see an ophthalmologist if it is a serious eye problem. Or if he says that you need to see a bone specialist if you have some orthopedician, if you something like that one there. So we also, as vibration analysts, we should also understand that there are certain problems which we can easily identify and prescribe medicines, and then the solutions are simple to be executed and the results will come out positively. However, there could be certain problems where we can identify them and then escalate it to the management and say that this is not the complete task of a vibration engineer or the existing maintenance team or anybody. You need to consult the OEM or other experts to resolve the problem there. So that's what I'm trying to focus in this particular talk. So this talk discusses the above relevant inputs from the real world case studies. In order to highlight my concept of these 7 stages, I would like to bring a few real world case studies where I was involved in the data collection and analysis process, and then where you can see the serious limitations which a vibration analyst will have in diagnosing the problems. So now coming back to the 7 stages which I told before, the first stage is the design stage. So what is happening in the design stage? As you go through the slide which is presented on your screen, all our rotating machines are comprising of various elements such as the rotors, blades, impellers, seals, bearings, couplings, casings and housings, foundations, piping, ducting, and whatnot. So a rotating machine is not a simple one component there. It comprises of various things. And then these are designed by a group of people. Rotors are designed by somebody, blades are designed by someone else, bearings are designed by another company, seals are designed by another company, couplings are designed by another organization. So now these designing process, people are using certain input for the designing application. So while designing the above elements, many parameters are considered to achieve the desired objective for a particular equipment. Now, if these parameters are altered at a later stage for whatsoever reasons, then the equipment might experience high vibrations during the subsequent operation. So if there is any certain things, if the machine is not performing or if they're not working as per the design conditions there, then that is the first stage where the machine can suffer high vibrations there. Something going wrong at this stage. So for example, so when we have a flaw in the design stage there, when does it surface? It comes out during the first operation or the commissioning stage. Or sometimes some machines can successfully get commissioned, but the problem can come after a few weeks or a few days or a few years later also, when the design stage, because the problems do not surface so easily sometimes. Now, when you consider referring to the first situation during the first operation commissioning, some of these examples which comes to my mind, which are design related problems, is like the rotor or bearing instabilities. In simple words, we call it as the oil whirl. So if the bearing is not adequately designed for that application, it starts showing unstable problems there, and that surfaces most of the time during the first commissioning itself. And then when some other problems which are design related may surface after a long time, which are related to the coupling problems, coupling design problems or impeller design problems, or if there is any inadequate foundation designs or the structural and piping. So those are the things which the failures can occur over a period of time, resulting from the inadequacy in the design concept there. Now, identifying the situation two problems means after the design stage, which machines have run after quite some time, it's a challenge to the vibration analyst. It's not so easy for us to analyze with the tools and the knowledge which we have. Next is the engineering stage. Now, when I said the word engineering here, I'm trying to consider a process of putting things together to achieve a desired objective. So engineering involves the selection and assembly of various elements, like a driver machine. It can be an electrical motor, or it can be a diesel engine, or a steam or a gas turbine, whatever it is. So a driver is selected to drive a driven machine, like a fan or a pump or a compressor or a generator. And then in order to transfer the power from the driver to the driven, you need to have the couplings, and there should be proper bearings to support these machines, and also a foundation or a structure which should be taking care of all these forces which these machines are generating there. So engineering is involving in consideration of all these components and putting them together. So when some errors occurs at this point of time, for example, if you have selected a driver and a driven, and then the coupling is not adequately selected to meet the requirements of transferring the entire torque or the power to the driven there, then once this machine is selected and installed in the plant, and when it starts running, there may be coupling failures, frequent coupling failures, or leading to other machinery damages. The same is the case with the bearings, or the same is the case with the foundation and all those things. Same case. Sometimes you select a pump with certain head and a pressure and a flow conditions, which is primarily considered for your application purpose. And then the driver equipment for an electrical motor may not be properly selected there. It may be either higher rated or under rated. In both the cases, if the motor is considered a higher capacity or a lower capacity, and then they are coupled together, then you will definitely face some vibration problems there. So when I say the engineering stage, this is what is happening behind the stage. So as a vibration analyst, when I start analyzing the vibrations under these conditions there, it is not easy for me to really identify these problems where exactly it is lying there. The same explanation goes here. So when you have an improperly engineered components existing in the machine train, So you may first see there the problem at the commissioning time or after some time. And as I told you, it could be a few days or a few weeks or a few years of operation also. So examples are the components. The situation is related to bearing failures, seal failures, couplings, and all those things there. Now the third stage is the manufacturing stage. Here what happens is all these components, most of the machines which we are dealing with, some of them are very high speed machines, and precision clearances and precision dimensional tolerances are required there. So failure to meet these dimension tolerances during the manufacturing or the assembly of these various elements stage, that can pave a way for high vibrations when the machine is put into operations. Of course, all the world renowned manufacturing companies have a stringent quality process to ensure that all these problems are 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 identified while the machines are being assembled and all that. Nevertheless, we do see some machines when they come to our plant, and you do when they are running, and ultimately you find out that something happened during the manufacturing stage. It was not properly assembled, or some components were missing, and then uh, the machine is giving us problems there. So this is the third stage. And when you come to the fourth stage, now what happens is if a machine is well designed, well engineered, and well manufactured, and brought into the site for installation there, the installation, these machines, depending upon their size, applications, and all that, they have a stringent installation process and all those things. And how what type of foundation is required, how they should be anchored to the foundation, how they should be connected to the pipings and ductings and all those things. If these processes are not properly carried out, or some lapse happens in these things, so then the installation errors can creep in, and then they can create high vibrations there. So this is the fourth stage at which a problem can enter into the vibration. A vibration problem can enter into the machine's life. Next one is the fifth stage. Now, if all the previous four stages, everything is going fine there, fifth stage commissioning is a happy-go-lucky situation. You just start the machine, you check the process parameters, everything is fine, the compressor or the turbine works well, there are no vibrations, or the vibrations are the normal within the acceptable limits, and then we commission the machine and have uh, uh, I should say a celebration at the end of the day that the machine is complete done. But if there are any sins committed at any of the four stages which I mentioned before, the design or the engineering or the manufacturing or the installation errors, the commissioning is the first stage where these problems are likely to surface out, and then we start analyzing them. And if these problems are analyzed in the commissioning stage, we should say that as vibration analysts, we should say that we should be lucky enough to identify the problem at that stage itself, because the complexity involved in solving the problem will be much simpler, because all the parties will be present. You will have the OEM people present there, you have the all the concerned people will be present around the machine to address the problem. But if the commissioning is done smoothly and no problems have come up during the commissioning time, then what happens is machine is handed over to the operation. Then the story is going to be different now. As we see that all these machines are designed to be operated under certain conditions there. So you cannot just run a pump the way you want. You cannot run a fan the way you want. If you want the fan to run without any problems, without any vibrations or any other issues and all those things, with the high efficiency condition and all those things, you should operate them as per the design, as per the conditions prescribed by the OEM. So all rotating machinery are designed to operate at specified conditions in terms of the load, speed, temperature, pressures, and everything there. Now, when deviation is taking place from these parameters there, then the machines are likely to show vibrations. Now, as we see that during operation, there could be a transient phenomena. For example, if you are having two pumps running, let us say there is three pumps are there, two working and one standby. And if the standby pump is taken to service, during the process, one of the pump load may be reduced, the other pump load may be increased, and all those things. So then that's for short duration of the time, you may be trying to deviate from the normal prescribed operational conditions. Either the pump discharge may be on the higher side or lower side, or flow may be on the higher side or lower side, whatever it is, when the sharing is taking place, when the changeover is taking place there. So those are transient phenomena, and those vibrations, they may not cause a permanent damage because they're normally short-lived. Maybe within an hour or two, you'll be able to stabilize the system there, and the vibrations will come to normalcy. But if you try to see situations where long-term operations are performed on these machines under the deviation conditions there, then they can be detrimental to the machines, and they create high vibration problems on that one there. So this is the sixth stage and the operation stage. Now going to the last one, the maintenance stage. So equipment maintenance is the seventh stage for introducing the vibration problem. That is according to me actually. And all rotating machinery is designed for maintenance through specified procedures. There are stringent process to be as to how the machine should be dismantled, how it should be assembled, and what are the clearances checked at various stages, and specific tools that needs to be used for assembling and putting back the components and all those things there. So if the procedures are deviated, and if you are not using the skilled manpower, the trained manpower for all those things, then these maintenance activities can sow a seed for the vibration problem. And once you put the machine back into service after the so-called maintenance activity, then you may find a high vibration on the machine problem there. So these are the 7 stages during which a vibration problem can creep into the machine's life. The important statement here is the ease of correcting a vibration problem at the field. It will decrease as we proceed from stage 7 to 1. Means as long as the problems are in the maintenance and operation regime, it is easy for a vibration analyst to identify and correct them, and then the solutions are fairly forward and simple, and the solutions, and it is easy to be manageable within the available resources. But if the problems are related to installation, manufacturing, engineering, and design, it is not in the purview of a vibration analyst to find the solutions for them, because his knowledge and the tools available with him are not adequate to address these problems there. So that is what I basically am trying to tell you here. So, and even the so-called category 2, category 3, or category 4 specialists who are certified by various certifying authorities in the vibration field, I definitely feel that their knowledge is also limited when it comes to the problems addressing any engineering or design or manufacturing problems there. For example, if there is a coupling failure, a frequent coupling failure between a pump and a motor, so I don't think a category 4 engineer is capable of selecting the right coupling for that particular application there. There may be exceptions for all these things, but most of us are not really do not have adequate knowledge and experience to carry out all those engineering and design activities there. So as I told you, just like a general physician, we should be able to identify what are the problems which we can comfortably resolve with the available tools and knowledge which we have, and which are the problems which require the attention of a specialist like a cardiologist or an ophthalmologist or a dermatologist or whatever it is, like those people there. So either you need a specific rotor dynamics engineer, or a bearing design engineer, or a coupling design engineer, or a compressor specialist to address the process oriented problems that are coming on the machine. So we should be able to identify it and put the ball in their court through the management there. So we should not take all the blame on our head and say that and try to solve the problem which is not basically our cup of tea. So this is the basic message I was trying to drive through this presentation here. Now I'll walk you through a few cases where the problems involving these stages, that is the design stage and the engineering and the manufacturing type of situations, are coming up there. Now, what you should also understand here is, if it is in the stage in 6 and 7, operation and maintenance oriented problems, see, the resources mostly are available within the plant. Maintenance people can handle it, change the, or look at the alignment or balancing, we can do the balancing. And if you want to change the bearing can, you can have a spare bearing to replace the bearing, and all those things are fine. And the time and resources are normally adequately available. But when it comes to the problems related to the design, engineering, and all those things, you need more lot of amount of resources, and then the cost and the time involved is going to be tremendously high depending upon the situation of the problem there. And sometimes it can take a few years to get a complete resolution on the problem, or sometimes we may, if the cost is going to be exemplary high there, sometimes we may decide to live with the problem and then continue to run the machine under the same conditions, because the corrections could be quite exceptionally costly there. Now let us show you. I'm going to show you the first case is of an electrical generator. It is related to the noise and frame vibration situation. So this is a large electrical generator, a 500 megawatt generator. The machine ran smoothly for about 2 years after commissioning, and there was no issues, there was no vibration problems or nothing on that one there. But after 2 years of normal operation, suddenly there was a change in the noise level coming from the generator. Normally, you know, these electrical machines, they start having some humming noise coming from them. So this electrical humming noise, generator noise, changed. So then we made a measurement. We found out that the previous values were around 85 dBA. And now when the noise level was increased, when we observed the change in the noise level, we found out that it has increased to around 90 dBA. So there is around 5 dBA change in the generator noise level. Definitely there is something inside the machine that is creating the higher noise level. Then the frame vibrations on the generator's frame, it's not on the bearings, huh? It is on the generator frame, the structural framework. It was data is collected. Frankly, it is not normal practice to them. But somebody advised that why don't you, because the noise is coming from the generator frame, from within the generator, let him make a vibration survey on the frame itself. And when we did the normal vibration survey and took the spectrum was showing 100 hertz as the dominating frequency, and it harmonic content 100, 200, 300, like that one there. So predominantly the machine is it's an electrical generator. So it's in India it is 50 hertz. So it is operating at 3000 RPM, or the 50 hertz is the 1x component there. But on the frame vibrations, there were no 50 hertz components present. It were all 100 and R harmonics there. So basically it suggests that it is something electrically oriented sources are present in the machine. Then what another important observation is, noise was found to vary with the grid frequency. And then when the frequency was as low as 48 hertz, the noise level was on the higher side. And when the frequencies are where the normal frequencies at 50 hertz are slightly above than 51 hertz or so, the noise level was reducing. So it happened to be a function of the grid frequency also. So then this data was compiled and shared with the OEM, because there's nothing which the field engineers, nobody understands what is happening on the generator. As the vibration analyst, just data was collected and the problem was presented before the OEM. OEM said that they wanted to have some internal inspection of the generator stator and the winding and all those things. So when the opportunity was given for inspection, internal inspection was indicated that possible modification in the stator structural integrity leading to resonance in the vicinity of the twice line frequency. So what the OEM was identifying is the internal inspection has found out that there is some structural rigidity has reduced in certain locations, paving way. So the change in the stiffness of the system, when the stiffness of the system changed, it modified the resonance, and in the worst case, now the resonance frequency, the natural frequency will shift, and it will be close to one of the excitation frequencies. So this natural frequency is close to a 100 hertz component, and a two-pole generator normally generates a 100 hertz component there. So that's how the high noise levels were coming, because coming from the stator winding vibration, stator structure vibration. That's what is happening there. So then OEM, based on this analysis and everything, they carried out stiffening modification to the stator system. Now, if you have seen normally any generator, there will be manholes on either side to gain entry into this one. Normally, they will be given at the center of on the actual location at the center of the generator frame. So you'll have access only to the center frame there. So the so-called modification was done only at the center of the generator there. And then when the machine was put back in service after the stiffening carried out inside, during the operation after modification, it was observed that the generator noise level was reduced. So the noise level has definitely come down compared to it came down to less than 85 dBA. But now what happened? But the frame vibrations drastically increased. Before we had the high noise level and the frame vibrations were not very high. Maybe let us say around 5 to 10 mm per second or something like that. Now, after this particular modification, noise level reduced, but the frame vibrations where we were normally getting at on 5 or 5 mm per second or something, now we are finding around 10 or 15 mm per second at the same location. Now, what we did is that we cured one problem, but we invited another problem into the system there. So, and then the OEM did further analysis, and then they now find out that now the resonance condition now transferred onto the earlier it was limited to the generator, the winding that is stator framework, but now it is transferred onto the structural frame, the supporting framework there. So analysis suggested the frame is under resonance now at operating speed. Then they further carried out some investigations, and then they suggested that in order to change the natural frequency of the generator frame, no, here again you can have two parameters. You change the mass or change the stiffness. So based on the generator structure, it is not easy to change the stiffness of this the housing. So they preferred to add mass, and you see 6 into 1.5 tons, around 9 tons of mass was added onto the generator structural frame to detune the frame resonance. Means, so by adding the mass, what you did was you reduced the natural frequency and brought it well below the operating speed. So the mass addition reduced the natural frequency and the generator continued in operation. So all these problems, now do you think that a normal vibration engineer can really take care of all these things based on his spectrum analysis and your phase analysis and all those things? Obviously no. You need to know, so this here a lot of people are involved, and again it is not a small machine, it's a 500 megawatt generator. And then you see the OEM is involved, and all the other higher level officials are involved in all these things, and this entire process has taken a long time. By the time the generator was cured completely of these problems, it has taken more than 2 years to completely resolve the problem. On the screen you are just seeing a few pictures which I was trying to show you. So this is on the left side top corner, you are seeing the generator general layout of the generator, and then this where on the circumferentially, these are the locations where the frame vibrations were taken at different locations there. And this is the inside of the generators, the reason for the noise, if you are seeing that caption here. So this particular shows that there is certain looseness gaps existing in certain locations of the generator structure, which is changed the stiffness of the system. So this particular dovetail bar is called as the core bar. On the right side in the picture, on the photo where you are seeing, this is the generator core bar. This is 1 bar, 2 bar, 3 bar, like that one, and these are holding the generator laminations which you are seeing here. So, and then there is another ring which is holding them. So this structural integrity, they say that some looseness has come up and some slackness has come up, and then that's the reason which is creating the generator noise. So they increase the stiffness of the system. Here you can see they added some structural components, and then they do some jacking arrangement to increase the stiffness. And these are the accelerometers that were added onto the system to get the vibration, to measure the vibrations. So once this top modification is done, noise level came down, but the frame vibrations, you can see that the bottom curve here. So here you can see the peak. This is the on the x-axis I have the speed of the generator, and on the y-axis we have the amplitude of the vibration and the phase of the vibration. You can see that the operating speed, the maximum vibrations are there, and there is also considerable phase change. So now this framework is under resonance there. So they have added 6 pieces of 1.5 tons mass. So 3 on left side and 3 on right side, as you can see from the picture here. So that changed the stiffness, and now on the extreme right side bottom corner, the picture you see, now the peak has come down drastically towards the left side. because you are increasing the mass, reducing the natural frequency. It has got down well below the operating speed there. So this is one case where we would like to present, where involving the design and engineering stages and all those things. Actually, probably nobody knows really what happened, where it happened, and all those things. But this is not a normal problem which can be addressed by a vibration field engineer at the field there. Definitely, you need the knowledge of a lot of engineering and other inputs to be design inputs to reduce to address this problem. And another problem here is, quickly we'll go through that. This is again related to FD fans, that is the 4 draft fans in a coal-fired power station there. And this is again a large motor. It is around 1 megawatt or 1.5 megawatt in power. So the fan drives a 1490 RPM axial flow fan, and it's an overhanging type with an impeller with 16 blades. Now these machines are having problems right from the day one of the commissioning itself. And by the time the problem was solved, it has almost taken 2 years. And all possible modifications were carried out. See, modifications carried out on the fan support framework. Original bearings were replaced with some another type of bearings. And then the blade mass was reduced to change the natural frequency. And in all this process, it has taken about 2 years to completely eliminate the vibration problem. And both the people who are owning the fans and the people who are supplying the fans have tremendous loss in expenditures in terms of time and production loss and all those things there. So this is the pictures which you can see. On the extreme right side, I'm showing you the general assembly of the fan. This is an electrical motor. You have a long cordon shaft around 1.5 meters or so. And then this is a bearing assembly, and you have the overhanging impeller, and the 16 blades are there. So this is the impeller with the 16 blades, and this is the blade mounting picture. And then this is the bearing housing. The bearing housing, as you can see, a cylindrical framework. And inside this, you have 2 types of bearings. I think they are cylindrical roller bearings on both sides, on both ends of these in the housing there. And as far as the modifications are concerned, this is the support structure, and it has come with certain stiffeners in the original design. After installation, there were a lot of structural modifications carried out on this fan. And then here also you can see that there were additional bolt holes that were provided to increase the stiffness at certain zones. And over a period of time, through analysis, they found out that the fan housing, the bearing housing itself is flexing, as shown in the picture here. The dotted line shows the way the machine is moving under operating conditions. And you can see that the support structural steel work is not adequate stiffness and all those things. So then they modified the bearing housing stiffness here. And then that modification led to a better situation. So these were all these things that were carried out, and the time span is more than 2 years, and in completely resolving this vibration problem there. So this is not a simple problem. You say it's a bearing problem, you stop the machine, you replace the bearing, and on the 3rd or the 4th day, you clap your hands and say the machine is back in service. No, these things are not as easy as they appear there. So this is another case one, which is related to a gearbox, which is in between 25 megawatt steam turbine generator trains. It consists of a steam turbine and a gearbox and an electrical generator. And the problem was on the gearbox. Three different sites, similar machines, all having the same type of problem on the gearbox. So the vibrations are on the higher side, and apart from the gear mesh frequency, we are having what is called as a ghost frequency. A ghost frequency is a frequency which is coming due to the errors introduced by the manufacturing tools on the gearbox, on the gear teeth. So three gearboxes at 3 different sites presented the same type of the problem. And then basically this is fundamentally because of some manufacturing error. The gear hobbing tool or the gear cutting tool which is involved, it has some errors, and it passed on the errors to these gearboxes. And then the data was presented to the OEM, and ultimately he agreed, and then he replaced the internals for all these things there. So this is one of the spectrum. I have just taken it for the sake of presenting it for you people. So here you can see these ghost frequencies when I mentioned. So those are not related to the machine configuration. These frequencies amplitudes are high, but they cannot be correlated to any of the frequencies coming from the machine configuration, gear mesh frequency or fractional gear mesh frequency and all those things. Those are fundamentally coming because of the errors introduced to you the manufacturing here. And finally, I have come across quite a few air handling equipment. They were large in number, and all of them having some problems which are having inadequate stiffness support problems and all those things. It was almost I was involved in examining around 30 or 40 machines of various ratings, and all of them were having a field unbalance problem or the structural rigidity problem there. Now these are all brand new machines which were brought into the site for installation there. How can they have high unbalance problems and structural rigidity problems there? So some homework was not properly carried out by the design, engineering and manufacturing teams at their works there. And lastly, this is a noise related problem for a HT electrical motors. And from the commissioning, high noise level was observed. High humming noise was observed from these motors. And then the analysis suggested that these frequencies are related to some stator and rotor magnetic fields. They don't fall under, and it is not indicating any mechanical or electrical problem on the rotor, not like rotor bar cracks or air gap variation. No, not such problems are not there. The motor is otherwise healthy, except for the high noise level that is coming from that one there. And then this data was shared with the OEM, and that OEM said that this is a combination of some stator and rotor slots combination that is coming up and creating the high noise level there. So this cannot be easily corrected. Either you have to replace these motors or send these motors to our works and we have to rework and all those things. It is going to be a costly affair. So the customer decided that, and let us operate this machine and see if there is going to be any degradation in their performance. So I was involved in the data collection and analysis, preliminary analysis and all those things, and these machines ran without any problems for more than 5-6 years, as long as I was there present in that particular site. So the motors were inside without experiencing any failures there. But this is again an abnormal noise. It's a noise is annoying to the people moving around the machine. It is singing some songs which is not pleasant to our ears as such. So this is not a situation which an operator who is spending 8 hours around these machines would like to spend his time there. So gentlemen, these are some of the things that I thought of sharing with you all people. So this is the conclusion. Addressing the design, engineering, manufacturing, installation issues at the site is not possible with standard vibration analyzers and their related software. And the people also, even if a category 4 specialist also, we don't have the complete tools to analyze the problem. So advanced tools like finite element analysis, model analysis, etc., and also along with the OEM intervention is required to address these problems. And field analysts must be aware of these limitations and highlight to their management for escalating the problem to the appropriate resources there. So we should be like, as I told you, coming to the same example, as a general physician, as a doctor, you should be able to identify and understand what are the diseases which you can comfortably treat for the patients who are coming up, or what are the diseases which you need to escalate it to the concerned specialists for their proper treatment there. So this is the message I would like to pass on to the vibration analysts for the people who are attending this particular webinar. Thank you very much for your patient listening. And if you have any questions, I'll be happy to answer them.
Yeah, great, sir. Thank you so much. It's a great insights about the approach, how we should start as a vibration analyst, how we should look at from design perspective, from design to, like a disposal, we can say that. So complete life of the rotating machinery. So how we have to look at and what are the stages which, the problem can enter into that, and how we should approach it. So it's a great insight, sir. Thank you. Thank you so much for sharing your knowledge with all. And thank you for all the attendees for listening to us and listening to sir. And please, if you have any questions, type them in the question panel, and we'll be like sir, we will be able to answer the questions. Yeah, so great. I think, some of the vibration analysts in some plants have been involved in the different stages. Like there are some typical jobs which they carried out, like collect data, do analysis, and give them reports. What are the abnormality you find. But some of the engineers or analysts also involved in the, like a FAT and acceptance testing and also some inspections. So that's a good approach, and we have to be part of the acceptance testing. And also there are stages which are involved. We also should be involved so that we can understand the problem more in detail. Yeah. So yeah, there are some questions and feedbacks here. Thank you, sir, for very informative presentation from Manish Kumar Saxena. And yeah, it is. Thank you so much for different task vibration diagnosis, Mariappan. And I have a query regarding identification of stage 1, 2, 3, and during construction, even management pressure to complete the work, identification of the problem is very rare. Yes, yes, Sanjay. So I understand that there are some situations. Yeah, and there's- yeah.
Actually,
So there's a question from there's a question from Praveen Kumar. What are the possibilities or trends AI technology in vibration analysis?
artificial intelligence.
Yeah, artificial intelligence. I think so. AI technology in vibration analysis.
Actually, of course, I don't think this is such a large gathering where I need to say, but somehow I am not in favor of this artificial intelligence to address these problems. The artificial intelligence is as strong as the algorithms or the process you build into it there. If there is a new
Yeah,
problem or something there, it cannot really identify it. If a bunch of people sit together and then they ponder over it, they may come up with the solution. Artificial intelligence is a useful one, but with the serious limitations on that one, especially on the vibration field. I don't think that it will have it will does a great help to us in diagnosing big problems on that one there. Personally, I am not in favor of artificial intelligence as a great support for the vibration analysis.
yeah. Yeah, good sir. So like there's a question from Balendra Kumar, how to differentiate whether the problem is related from 7 topics or 7 stages versus incipient problem related to the field conditions. Yeah, like how to differentiate the problem, whether the problem is from these seven topics or 7 stages, or it is from the field. How to differentiate that, that's the question.
See, see, from the field, where does it, if it, see, ultimately we are doing this job only in the field itself. So whatever is the contribution that is coming from the field will be falling under these categories. As I told you, if the machine is normally designed, well engineered and installed and commissioned there, the normal problems will be only a normal aging problem that will be there. The machine has run for 5 or 6 years, then there will be a bearing problem. So you change the bearing, and then the vibrations comes down. And if then there could be some excessive clearance or something, the alignment may change like thing. So you go in for change, you realign the machine. So those are the things which you can normally collect there. But what I'm trying to say, there are some chronic problems, especially these design related problems and all those things are chronic problems where they don't disappear, and sometimes they may be existing. Then they may start coming from your commissioning stage, or they may start coming after 2 or 3 years, and then your conventional analysis and all those things will not give you a solution. For example, you thought that it was an alignment, you realign the machine, and then you start the machine, still the vibrations problem is there. or you think that it is a balance problem. You go on doing the balancing, but it doesn't respond and all those things. So that's where you should think that it is a problem which is to be escalated to a higher level there.
Yeah. Okay, so there's a question from Jignesh. After refurbishment, which standard we have to follow, like API or ISO, especially in steam turbines or BFW pump rotor during FAT?
See, normally ISO is for casings, and of course ISO is also there for the shaft vibrations also. Especially, I think ISO 20816 part 2 or something is for gas turbines, and part 3 is for steam turbines, I think. So they try to give you all that one. So the standards is basically up to you. And normally, if you are in a refinery, most of the time you going for, if you are in a refinery or a petrochemical complex and all that. So most of those standards, people look for API as a reference guides there. But if you are if you are referring to turbo machinery in power stations or in other applications and all those things, most of those people they go by the APS, go by the ISO reference standards as such. So, but ultimately, again, the standards are also only the guidelines. Just because according to the standard, the machine is having high or low vibrations, that doesn't always confirm that the machine is healthy or sick. You should have your own way of judging the condition also. You should also understand that all these standards, they'll say that these are guidelines only. You have to make your own judgment based on the condition of your local conditions and the other parameters which are governing the machine performance.
Yeah. Yes, sir. So I agree. So, like the question from Amit Mishra, do we need to understand the process and working of machine to resolve the vibration problems?
Yes, it's
Yeah.
a good question. Actually, what I should say is a vibration analyst. See, let me tell you, at the start of my career, I thought that as a vibration analyst, I need to be only a mechanical engineer to understand this thing. But no, you need to be, you should be like a jack of all trades in order to be a good vibration analyst. You should have a process idea about how a gas turbine is started, how it is loaded, how a compressor is started, how it is loaded, what are the various process parameters which influence the compressor behavior. All these things are required. And a little design knowledge, a little engineering knowledge, a little maintenance knowledge, operation knowledge, all these things are very essential, because your spectrum alone or your space alone is not going to tell you. It tells you where the problem is. But in order to really identify and segregate the source of the problem and relate it to these various behavior, you need to consider all these parameters. Of course, every time they may not be required. Sometimes sometimes the vibration data directly it will be able to help you to resolve the problem. But sometimes you need to, depending on the behavior and the response of the machine, you may need to correlate to the various process parameters and other operating conditions also. Sometimes the machine will be behaving roughly when it is passing, when it is in the transient condition, and otherwise, and sometimes it may be rough under normal, under some process changing conditions and all those things. So that's how well you should be able to understand what are the conditions that are influencing the overall vibration behavior there. So basically, I generally suggest that all the vibration analysts should have a good knowledge about all these things. We need not be specialists on this one, but you should have adequate knowledge about when the compressor is surging, what is happening on the compressor there, what parameters are changing. If the steam turbine, gas turbine is starting from here and then it is getting loaded there, what are how the parameters are changing and all those things. So that knowledge is sufficient to understand what is happening on the machine. As I told you, some problems are within our purview, but later on, then you can escalate it to the higher, the appropriate resources team as such.
Yeah. So a question from Fadi Ibrahim. So what are your recommendations to a Cat 4 specialist to further develop and address complicated cases that you present, in addition to get help from OEM?
See, it is not, see, frankly speaking, if you look at the category 4, see, category 4 is just it's just the tip of the iceberg of the general vibration problems which we come across. Actually, I would suggest that for the people who are interested in understanding and then getting a good information about the process of the turbo, especially focused on turbo machinery and related to oil and gas environment. This turbo machinery pump symposium conducted by the Texas A&M University. If you go into the Google and search for turbo machinery pump symposium, you will get, it will take you to their website. Go into their proceedings. And nowadays, all the proceedings right from mid 70s till 2022, all the proceedings and are kept in their website there. It's all that knowledge is yours. If you go into them, there are excellent case studies addressed by various people, like a group of OEMs specialists and all those things, and then and the people who are working in the field. A wealth of information is available there. If you can tap that particular resource there, you will get an exposure to a tremendous amount of turbo machinery related information there, and that will and then the sky is the limit for us to understand that one there. So whether it's a category 4 or anything, but that doesn't matter. When you are depending on the type of machines, see, if you are looking at a cement industry, those machines, 50, 60 or 70% of the machines are common to all the industries. Pumps, fans, all those things are common to all the rotating machines there. But when you go to a cement plant, there are certain rotating machinery which are particularly seen only in cement plant. If you go to a paper industry, there are certain machinery which are only typically in the paper machinery. And an analysis of that one, you require the knowledge of the process and the design and everything over there, how the machine is laid out, how it is performing, and all those things there. So you cannot. So the category 4 is basically, frankly, it doesn't give you. It's just a certification. Frankly, telling you there, it doesn't elevate your knowledge or anything. It is your exposure and then the quest for you to learn about all these things. That's where that is what will take you to greater heights. The certification is just a paper in your hand, and of course it will help you to open doors for certain things, but I don't really believe that this is going to enhance your knowledge. A certificate in your hand is not really going to enhance your knowledge. The
Yeah.
thirst for the knowledge is that you meet the people, and then you get from these, as I told you, the websites. There are a lot of websites nowadays. A lot of information is available there. You tap the resources there, and that will show you a good give you a good knowledge on this analysis process.
Yeah. Good, sir. So there's a question from Janardhan Muralidharan. So while reviewing the vendor documents, what checks to be done on rotor dynamics report to avoid the issues? Even though we refer many issues like to happen in other stages as well. Please advise.
See, actually, again, if see these normally, as far if you look at the oil and gas environment there, that's where a lot of streamlined documentation is. API standards, as I told you, American Petroleum Institute standards there. So they try to give you, for example, if you are buying a steam turbine or a gas turbine or a for refinery applications or a gearbox or a centrifugal compressor, there are certain API standards, API 612, API 614, 616, or something 617, like that one. So they try to give you in that standards a lot of the rotor dynamic information, general information is available there. So if, for those application, you can go through this one. But otherwise, normally what happens is for the other industries like power stations or the other applications, what you basically need to understand here is ask for the general analysis of the rotor dynamic analysis of from the OEM, and then you try to get it vetted. If you have the enough knowledge to evaluate their document, it's fine. You yourself can evaluate and find out how the calculations are carried out about that particular machine there. But otherwise, then you can hire a consultant who is having adequate knowledge in the rotor dynamics, and they can help you to understand the authenticity of the document presented there and all those things. But that's what comes to my mind to answer your question.
Yeah. Great, sir. Thank you. Thank you for clarifying all the questions. So we got many questions, so it's difficult to answer all of them. But attendees, thank you so much. You can write to learn@spectransys.com if you have any further questions. And also you can look for, the upcoming webinar that is on the 16th September, Saturday. 10 a.m. to 1 p.m. and on the topic, challenges of turbomachinery vibration analysis. Yeah, that's a great evening, sir. Thank you so much for your time and sharing your knowledge with all the participants. And thanks once again to all the attendees. And meet you soon in the next webinar. Thank you, sir. You would like to
Thanks,
sign off? Yeah,
thanks everyone.
yeah, yeah. Thank you all. Thank you so much.
Okay,
Thanks and have a great evening and great weekend. Thank you. Thanks all. Bye.